right, everyone, welcome to your very last data demonstration. Hooray! So this one, we're going to be looking at logistic regression. So go ahead, let's open up PSPP. Let's get our 2022 General Social Survey up. And just like with linear regression, with this one, I have some help for you. So I want you to use the provided syntax file. You can get this on Canvas. And this is just to, again, help us get going, help us get started so we don't have to do all this stuff in this video, which would be awful. But we are going to be exploring the question of whether or not money can buy happiness. And we're going to be looking at happiness through the lens of social class, race, and sex, which is, there's this hypothesis or kind of theoretical viewpoint called CRS, or CSR, sorry. Now I have that backwards a little bit, where it's class, sex, race. And the hypothesis is those three things are highly influential in looking at inequality. So we aren't looking at inequality, but rather happiness. So the first thing we need to know is how our variables are measured. So I just want to show this to you real quick. You don't have to do this part yet, but I wanted to show you two variables. Happy and happy 7. So happy is the version of happiness that the GSS has been using since like the 70s. And let me show you what it looks like. Cleared out my output. Here we go. So happy just has very happy, pretty happy, not too happy. And there's some problems with that variable. I mean, it's not very balanced. And it may not do as good of a job describing how happy people view happiness today. So we're going to use happy 7. And in happy 7, we have a few more categories. We have completely happy, very happy, fairly happy, neither happy nor unhappy, fairly unhappy, very unhappy, and completely unhappy. And as you can see, there's definitely a happiness bias. And I think there's a book with that title. In the United States, people tend to over-report how happy they actually are. But since we have multiple levels or measures of happiness, we're going to collapse this into two categories, where we have 1 being completely and very happy and 0 being everyone else. We're going to put fairly happy in with the neither happy nor unhappy because we're interested in kind of the extreme. We want to know if people really are like happy. So how are we going to do this with syntax? Let's walk through the syntax here with you real quick. So here's happy 7. So I created a dummy called happy 7 underscore D. And again, we don't have time in this video to cover how to make dummies. Hopefully you've already learned this. But we have the very happy and completely happy, or completely and very happy people being 1 and everyone else being coded 0. Here's social class. Since social class, there's 4 groups. We need 4 dummies. So I just called those dummies lower class, working class, middle class, upper class. And you can see how I coded those. And then male D, I thought we'd use males today. So females are the reference. And then with race ethnicity, we're just using race 3. So first we create the variable and then we make the dummies. And on this one, if you notice, I used the fancy tilde. So a tilde before the equal sign means does not equal. So if race 3 equals 1, which means they're white, non-Hispanic, white D is 1. If it doesn't equal 1, then it's 0. All right. Now, one weird quirk with logistic regression is that this is like the only place this ever does this. When it says measure here, see how it says like scale, nominal? There's an ordinal one too. We need to make sure dummies are set to scale. So if you don't do that, it's really going to like screw up your data. So there is a nifty little bit of code that you can use called variable level. And in that one, we just write variable level, the variables that we want to turn to scale, and then in parentheses at the end, scale. So I got these variable names just by doing a frequency and hitting paste and copying and pasting it over. All right, so let's run this syntax. I don't know if I cleared out my output before. I'm gonna run it again. Okay, so we're looking for any errors. Oops, that's not our output. Here's our output. No errors. Sweet. And we always want to check our variables, right? So um, I think it'd be wise if you checked yours just in case. So what I'm going to do, I'm going to run some frequencies. I'm going to find happy 7, put it in, and then I'm going to get my happy D. I'm going to put class in next, and then I'm going to put in lower through upper. I guess technically you don't have to do this part if you don't want to. Then I'm going to find the variable sex, put in male D, race 3, and my race dummies. It's always, always, always a good idea, though, to check to make sure your recodes look good. But since you are using my syntax, I guess you don't have to do this part. We can just check it together here. So here's happy 7, the original. So we're doing is looking to make sure these numbers kind of match up. So I'm looking over here at the cumulative percent, 45.5, and it matches the 45.5 here. Subjective social class, we should have 452 lower class. We do. Working class, yep, looks good. Middle class looks good. Upper class looks good. For the variable sex, okay, we have 1,910 males. That's what we have in male D. Race 3, yep, looking good. Sweet. Okay, I'm going to close this out. All right, so now for sure's, you're going to follow along. Okay, now one of the really cool things about logistic regression is we don't have to run the analysis twice. We don't have to run it once with weights off and once with weights on because you'll see it gives us the unweighted sample size. So let's go ahead, turn on our weights. And let's go run our analysis. So we're going to come down here to regression, binary logistic. Our dependent variable, that's going to be happy 7D. And now we're going to do class, sex, and race. So for class, we have to decide who's going to be our reference group. Let's make lower class our reference. Since the question is, can money buy happiness? We probably want to see what happens as class goes up compared to those that are lower class. So let's put in working, middle, and upper. We'll put in male D. For race, let's put in, I want to make Hispanic the reference. So let's put in white and black, okay? And then click OK. Oh, not OK. Ah, dang it. Be sure to click options and the confidence interval for exponential B. That's our odd ratio. All right, let's look at our output. So at the end of the day, this is what I want you to turn in. So let's just start at the top. I'm going to try magnifying. Hope that works. All right, so here 1 is 1. That's good. This is our happy variable. If this is swapped, then that's a problem, right? Because then we're not actually predicting the odds of happiness, we'd be predicting the odds of not happy. We look here at our included analysis. We're missing quite a few cases. And most of that is because happy 7 wasn't asked to everyone. It was only asked to about 2/3 of the sample because they're testing it. So we need to be aware of that, but this is still a pretty good healthy sample size. We come down here to our Nagle-Kirky R-squared. It's only a 0.04, which is pretty low. So that probably means that our model is not doing a very good job of predicting the odds or explaining what predicts the odds of happiness. But let's come down and look at what we got. Okay, remember, we don't interpret this B here. This is the log odds. We can use it through this complicated process, but we're not going to. It's more common to use the exponential b, which is the odd ratio. So when we talk about odd ratios, right, this is a number that reflects the relationship between two odds. It is not an odd or a probability. But how we would read this is that those that are working class, their odds of being happy are 2.92 times greater than the odds of those that are lower class. And you can see that as class goes up, that also goes up to where the upper class people, their odds of being happy are 4 times the odds of lower class people. So, yes, it does appear that money is buying happiness. And you can see that they are statistically significant. And here's our confidence intervals. Notice how, like for upper class, it's kind of a wide one. Same here with middle class. They're all pretty wide confidence intervals. And that's probably because there's considerable variation in happiness. But even with that variation, we can still be really confident that those that are upper class, their odds of being happy are anywhere from 2.5 to 6 times, more than 6 times that of lower class people. Okay, then we come down here. Males, their odds of being happy are, if it's lower than 1, that means it's lower odds. And we would take 1 minus this. So that would be 0.15, sorry. So males, their odds of being happy are 15% lower than the odds of females when controlling for class and race. All right, let's look here at race and let's see what we have. Now we have to remember who's our reference? Hispanic. Okay, so white non-Hispanics in comparison to Hispanics, their odds are, you know what? It'd be 25% lower than the odds of Hispanics when controlling for everything else. Now for blacks, we can't say it's 10% because it's not significant. So we can't actually say, and we shouldn't say, that there's a difference in the odd ratios between, or the odds between blacks and Hispanics being happy when controlling for everything else. So this is very interesting stuff. Oh, and since we had our weights, or because we're logistic regression school, our weights are on, so we're good using these. But the nice thing is this number here is unweighted. I just wanted to remind you of that. So we're doing good there. All right. Well, who knows? What else do you think might be causing happiness that we're not controlling for in the model? I mean, our Nagelkirky square is really low, right? Like, what about the effect of marital status? Or is even this measure of social class not really measuring money, right? What are other things associated with class that may, you know, predict happiness? It could be things like home ownership or having a car or having enough food or living in a good neighborhood. I mean, there's so many other factors at play here. But the cool thing is we can control for those factors. We can figure it out. All right. Well, good job, everyone. You completed your last data demo, and I will see you later.